In this demonstration, you'll learn how to set up a static structural simulation to study the results of pressure loading on a curved pipe. I'll start by selecting a simulation process template from the study panel on the left here. I'm going to select the structural template. I'll leave the default physics type of structural only. I can either do a static analysis or a modal analysis. In this example, I'll select a static analysis and accept the default selection for the options list so that connections in the interface of the bodies are detected automatically. In creating my simulation process, the first thing that I'm asked to do is select a geometry. I'll select the Design Modeler Geometry file for the curved 3-part pipe. AIM loads the geometry and sets up a simulation process with typical default settings for geometry, mesh, physics, and results. While this is not a particularly time-consuming process, it is not interesting to view, so I'll skip ahead. AIM has automatically created the physics solution process, which involves the geometry import, meshing, physics, and results. Here is a summary of all of the tasks created, along with their status. All of these tasks are also available in the workflow window in a data flow diagram format. Because the meshing task has all of the information it needs to produce the mesh, I'll go ahead and update it now. The meshing task is now complete. The physics solution task now requires more information in order to complete the simulation. I'll click on it to go into this task. You'll see that a lot of defaults have already been set up for me: material assignments, physics options, and solver settings. You can also see that 2 connections were created for this case. The blue button shows the actions that still require attention. Here I need to add some boundary conditions. First, I'm going to add a displacement boundary condition. I'll use the face selection filter to select the face at each end of the pipe. Then I'll add the displacement boundary condition from the context menu. This boundary condition is now up to date. Next, I want to apply a pressure to the inner curved faces of all of the 3 bodies. I'll start by selecting the 3 outer faces and hiding them. Now I'll select the inner curved faces of all of the 3 bodies. Then I'll right-click to add the pressure boundary condition. I'll set the pressure and then press Enter. You can see the magnitude value is also reflected here in the pressure panel. The pressure boundary condition is now up to date, and with those few additional settings, my physics solution is all set up. Before proceeding, I'll want to show all bodies again. And then I'll solve the physics solution task. I can see the progress on the bottom right-hand side here. Everything's updated, so now I can view my results. I'll click on the results task and then evaluate. I can then expand the results heading to view the predefined results. One predefined result shows the displacement of the pipe under the load. I can also use this pull down at the top to select my other results. I've got equivalent stress here. And if I like, I can right-click on the screen and animate my results. I can also add the force reaction result to view the reactions generated at the 2 fixed ends of the pipe. On the results panel, I'll select the Add button for results, and then select the force reaction result. Then I can evaluate and view the force reaction. This concludes this demonstration of an end-to-end basic static structural simulation in AIM.